All right, today we're going to take a look at another way that we can measure two-dimensional shapes. And today we're going to focus on an idea or a concept called area. This is indeed different than perimeter. We do not tackle it in the same way because it measures something different about shapes, two-dimensional shapes. The area of a shape measures the amount of space inside of a two-dimensional shape. So the difference between area and perimeter, area is measuring the inside of the shape, whereas perimeter is measuring the outside of the shape. So two very different measurements. And when you get into 6th grade, you'll understand a little bit more why area is measured in square units, although we are going to make some sense out of that right now. So we do indeed use these things called square units because what we're doing, the idea of figuring out area, is we're actually placing these squares into the shape to see how many of those squares fit into the shape. So this is one square unit right here because it's a square, right? It's absolutely a square. It's one thing by one thing. It could be 1 inch, 1 foot, 1 meter. I didn't give you the specifications, but we just know it's 1 unit by 1 unit. So what we want to know is how many of these square units, how many of these squares fit in here. Well, let's see. We've got 1 here, 2, 3, 4, 5, 6, 7, 8 of them. So the area of this rectangle is 8 square units. And we use what's called an exponent. We saw some exponents earlier this year when we did powers of 10. So what we're doing is we're squaring the units. So we're going to put a little 2 up in the corner. Let's use the same idea, just using this picture to figure out what the area, how many square units fit into this rectangle. So here is 1 square unit. Here's a second one. Here's a third one. Here's 4, here's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 square units. So the area here is equal to 15 units, and I'm going to put that square symbol, 15 square units, because 15 of these squares fit into or make up this rectangle. We do have formulas, so we're not always going to have to be counting up a bunch of little squares. We do have some shortcuts and some formulas that we can memorize that can help us to get to the answer a little bit more quickly. So the specific formula for the area of a square, we're going to look specifically at a square, is side times side. So oftentimes you're going to see me write it like this, A equals S times S. And then when you get into 6th grade and higher grade levels, what you're going to see using exponents, you're going to see S squared, because anything times itself is one way we can describe that is by using exponents, and it would be that thing squared. But for right now, we can just say side times side. So in this case, let's go ahead and figure this out. Well, what are these side lengths? So we want the bottom side. So 1, 2, 3, 4, 5. So this is 5 units wide, and it is 1, 2, 3, 4, 5 units tall. So this is going to be 5 units times 5 units, which is 25 square units. Now I want to again relate this to what the actual meaning. That means there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means there is a grand total of 25 of these squares that can fit into the larger square. So that is the area, because that's the amount of space that this square takes up in the inside. And rectangles are going to be the other shape we take a look at. The shortcut or the specific formula for the area of a rectangle is length times width, L times W. So the length here is 1, 2, 3, 4, 5, 6 units. And the width in this case is 1, 2, 3, 4 units. Okay, and what I can do instead of counting these up and saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth, because that's time consuming, I can actually just multiply them together and it will tell me the grand total inside of here. So in this case, this is going to be 6 units times 4 units, which is 24 units. And again, it's square units, so you put the exponent 2. And it turns out, yeah, if you labeled these 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth, there would be 24 grand total of these boxes, these square units, that fit into the larger rectangle. So this is what you can use, and this is what I call my geometry trifecta. You can ask the 6th graders. I really hounded them about this trifecta, and what the trifecta is, tri means 3, as we know with triangles. The first thing I'm always going to want to see is the formula. The second thing I'm always going to want to see is the substitution. And the third thing I'm going to want to see is the answer with units. All right, let's take a look at parallelograms and triangles. There we go. So other shapes have areas that depend on their base and their height. So here's something really important that I have found kids struggle with. In the past, kids have thought, oh, area formulas, I can use one formula for all shapes, and that is not true. Because shapes are so different in size and in shape, we have different formulas for these different shapes. So there is going to be a good deal of memorization when it comes to finding the area of these different shapes. So the base and the height of polygons are what we call perpendicular. Really fancy word, perpendicular. And all that means is that they form a right angle. If two lines are perpendicular to one another, it means they form a right angle, which is 90 degrees. And remember, the symbol we use for that, if we have a right angle, is that little box. So I'm already seeing a box here, so let's jump to the triangle right away. So I see this, and notice how I have a line here and a line here that are forming it. That's your base and your height. Your base and your height always have to be perpendicular to one another, which means form a right angle. Same thing with a parallelogram. If you notice, I know it's not drawn in here, but this makes a perfect L shape, which is indeed 90 degrees. So your base is this bottom thing right here, and the height is actually kind of inside of that parallelogram. I've had a lot of kids think this slanted part is the height, and it's not. The height must be perfectly up and down in relationship to the base. It has to make that 90-degree angle. So let's talk about the shortcuts and the formulas for these shapes. So in order to find the area of a parallelogram, you are going to multiply the base, B, the base, times the height. Okay, so the base, and I'll write that out. It's going to be base times height. And I'm using the dot as my multiplication symbol. If that's confusing you, I'm sorry. I can change it to the X, or the traditional multiplication symbol. So in this case, again, I'm seeing that this line here and this line here are making a 90-degree angle. So this is going to be my height, H, and 8 is going to be the base, or the bottom, the base. So this is going to be, the base is 8 centimeters times 6 centimeters. 8 times 6 is 48. And remember, we always square our units when we're dealing with area. They're always square units. And what that means, if I had a grid laid out, what it means is we could fit 48 of these little tiny squares that are 1 centimeter, by 1 centimeter. So it'd be a square with 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, and it means we could fit 48 of them inside of this parallelogram. And that describes how much space this entire parallelogram takes up on the inside. All right, and the last shape we are going to take a look at is triangles. So triangles have, they're similar to parallelograms, but the formula is definitely different. So the way that we compute the area of a triangle is it is 1/2 times the base times the height. Okay, so it's 1/2 times the base times the height. And again, the base and the height of the triangle have to be perpendicular. So if we look at this example right here, this line And this line, it is indeed forming that right angle, so they are perpendicular. So this is going to be your height, this is going to be your base, B for base. And when you do your formula, it has to be 1/2 times your base, which is 6 centimeters, times your height, which is 7 centimeters. Half of times half of 6 is 3 centimeters times 7 centimeters, and that's 21 square centimeters. So that's the area of the first triangle. Let's take a look at the area of the bottom triangle. So I'm going to use my trifecta. I'm always going to write the formula first. So I am dealing with a triangle. And this is the triangle right here. This stuff over here, they're trying to just kind of help you visualize what is actually happening. So here, your height is not actually inside of the triangle. Your height is to the outside. And what's saying is it's measuring the tip top of that triangle all the way down to the bottom of the triangle. And that's the height. So that's your height, and it is indeed perpendicular to this base right here. So your 4 centimeters is going to be the base. Now let's write out the area of a triangle. I always like to do what I call subscripts. I like to draw a little shape of whatever I'm solving. So the area of a triangle is 1/2 times the base times the height. You can use either multiplication symbol, the times or the dot. So this is going to be 1/2 times 4 centimeters times 7 centimeters. Half of 4 is 2. And 2 times 7 is 14 square centimeters. Your units must always be raised to the power of 2 when you are dealing with area. And so what this means is if I took those little boxes that are 1 centimeter by 1 centimeter, that's a square centimeter, I'd be able to fit 14 of them in here. And you might be thinking, well, we've got some slanted lines, and if I was trying to put like boxes in here, it wouldn't fit in nicely. And I agree. So the cool thing with this is actually what would happen is you'd cut it, and you would take this little piece, and you'd be able to fill it in somewhere else. So it does turn out that 14 of these full boxes, even though they're cut up and kind of placed in there like a jigsaw puzzle, that 14 of them would completely fill the inside of this shape, which is indeed its area. So why don't you go ahead and try the homework on your own. I do want to see your trifecta where you give me the formula. Then I want to see you substitute, tell me what the dimensions are, and then your answer with your unit. So I should see 3 lines of work when you are doing geometry.